Okay. Hi everyone, welcome back to this video series on Windows Server 2016 software-defined networking. The flexibility and the elasticity of cloud computing cannot be denied, and most technology executives are currently exploring their options for utilizing cloud technologies. One of the big stumbling blocks to adoption is trust. Cloud service providers, onerous computing power, all immediately accessible at the press of a button. But in order for companies to store their data on these systems, the level of trust that your organization has in that cloud provider must be very high. After all, you don't own any of the hardware or networking infrastructure that your data is sitting on when it's in the cloud. And so your control of those resources is limited at some point. Seeing this hurdle, Microsoft has made many efforts in recent updates to bring cloud-like technology into the local data center. Introducing server elasticity into our data centers means virtualization. We have been virtualizing servers themselves for many years now, though the capabilities are still being constantly improved. Now that we have the ability to spin up new servers so easily through virtualization technologies, it makes sense that the next hurdle will be our ability to easily move these virtual servers around when we need to. Have a server that you want to move into a data center across the country, migrating an entire data center into a new colo across town. Maybe you have recently acquired a new company and need to bring their infrastructure into your network, but have overlapping network configurations. Have you bought into some space at a cloud service provider and are now trying to wade through the mess of planning the migration of all your servers into the cloud? These are all questions that need an answer, and that answer is software-defined networking, SDN. SDN is a broad, general term that umbrellas many technologies working together to make this idea possible. Its purpose is to extend your network boundaries whenever and wherever you need them to be. Let's take a look at some of the parts and pieces available in Windows Server 2016 that work in tandem to create a virtual networking environment, the beginning of adoption to our software-defined networking ideology, Hyper-V network virtualization. The biggest component being focused on right now that brings the ability to pick up your networks and slide them around on a layer of virtualization is within Hyper-V. Makes sense because this is the same place you are touching and accessing to virtualize your servers. With Hyper-V network virtualization, we are creating a separation between the virtual networks and the physical networks. You no longer need to accommodate for IP scheme limitations on the physical network when you set up new virtual networks, because the virtual networks can ride on top of the physical network, even if the configurations of the two networks would normally be incompatible. This concept is a little bit different to wrap your head around if this is the first time you're hearing about it. So let's discuss some of the real-world situations that would benefit from this kind of separation. Private clouds. Private cloud is steamrolling through data centers around the world because it makes a tremendous amount of sense. Anyone interested in bringing the big benefits of cloud into their environments while at the same time staying away from the cloud negatives can benefit from this. Building a private cloud gives you the ability to have dynamically expanding and shrinking compute resource, the ability to host multiple tenants or divisions within the same compute infrastructure, and provides management interfaces to those divisions so that the nitty-gritty setup and configuration work is able to be done by the tenants themselves, and you don't have to spend all kinds of time and resources at the infrastructure provider level making the small detailed configurations. Private clouds enable all of this capability while staying away from the big scare of your data being hosted in a cloud service provider's data center, which you have no real control over, and all of the privacy concerns surrounding that. In order to provide cloud, a private cloud inside your infrastructure, particularly one where you want to provide access to multiple tenants, the benefits of network virtualization have become apparent and even a requirement. Let's say you provide computing resources to two divisions of a company and they each have their own needs for hosting some web servers, no big deal. But these two divisions both have administrative teams who want to use IP schemes that are within 10.0.0.0. They both need to be able to use the same IP addresses on the same core network that you are providing, yet you need to keep all of their traffic completely segregated and separated. This would have been a nightmare with only a physical network, but by employing the power of network virtualization, you can easily grant IP subnets and address schemes to whatever caliber each division chooses. They can run servers on whatever subnets and IP addresses they like, and all of the traffic is encapsulated uniquely so that it remains separated, completely unaware of other traffic that is running on the same physical core network beneath the virtualization layer. This scenario also plays out very well with corporate acquisitions. Two companies who are joining forces at the IT level often have conflicts with domains and network subnetting. With network virtualization, you can allow the existing infrastructure and servers to continue running with their current network config, but bring them within the same physical network by employing Hyper-V network virtualization. Another simpler example is one where you simply want to move a server within a corporate network. Maybe you have a legacy line of business server that many employees still need access to because their daily workload includes the LOB application to be working at all times. The problem with moving the server is that the LOB application on the client computers have a static IPv4 address configuration by which it communicates with the server. When the user opens their app, it does something like talk to the server at 10.10.10.10. Traditionally, that could turn into a deal breaker for moving that server, because moving that server from its current data center into a new location would mean changing the IP address of the server, and that would break everyone's ability to connect to it. With virtual networks, this is not an issue whatsoever. With the ability to ride network traffic and IP subnets on the virtualization layer, that server can move from New York to San Diego and retain all of its IP address settings, because the physical network running underneath doesn't matter at all. All of that traffic is encapsulated before it is sent over the physical network, so the IP address of the legacy server can remain at 10.10.10.10, and it can be picked up and moved anywhere in your environment without interruption. Hybrid clouds. While adding flexibility to your corporate networks is already a huge benefit, the capabilities provided by virtualizing your networks expands exponentially when you do finally decide to start delving into real cloud resources. If and when you make the decision to move some resources to be hosted by a public cloud service provider, you will likely run a hybrid cloud environment. This means that you will build some services in the cloud, but you will also retain some servers and services on site, at least for a while, though I foresee most companies staying in a hybrid cloud scenario for the rest of eternity, as a 100% movement to the cloud is simply not possible for the ways that many of our companies do business. So now that you want to set up a hybrid cloud, we are again looking at all kinds of headaches associated with the movement and resources between our physical and cloud networks. When I want to move a server from on-site into the cloud, I need to adjust everything so that the networking configuration is compatible with the cloud infrastructure, right? Whatever IP subnet they assign to me, wrong. As long as you have your network virtualization infrastructure up and running, once again, software-defined networking saves the day, gives us the ability to retain the existing IP address information on our servers that are moving and simply run them with those IP addresses in the cloud. Again, since all of the traffic is encapsulated before being transported around, the physical network that is being provided by the cloud does not have to be compatible or distinct from our virtual network. And it gives us the ability to seamlessly shuttle servers back and forth from on-premise to the cloud without having to make special accommodations for networking. How does it work? So far, all of it sounds a little bit of magic. So how does this actually work, and what are the pieces that need to fit together in order to make network virtualization a reality in our organization? Something this comprehensive surely has many moving parts and cannot be turned on by simply flipping a switch. There are various technologies and components running within a network that have been enabled for network virtualization. Let's do a little explaining below so that you have a better understanding of the technologies and terminology that you will be dealing with once you start your work with software-defined networking. System Center Virtual Manager. Microsoft System Center is a key piece of the puzzle for creating your software-defined networking model, particularly the Virtual Machine Manager, VMM, component of System Center. The ability to pick up IP addresses and move them to other locations around the world requires some coordination of your networking devices, and VMM is here to help. This is the component that you interface with as your central management point to define and configure your virtual network. System Center is an enormous topic with many options and data points and won't fit into books that you are reading today. So I leave you with a link at a starting point on VMM learning, https technet.microsoft.com/enus/library/GG610610.aspx. Network controller. Microsoft's network controller is a new role in Windows Server 2016, and as the name implies, it is used for control over network resources inside your organization. In most cases, it'll be working side by side with VMM in order to make network configurations as centralized and seamless as possible. Network controller is a standalone role and can be installed on a server 2016 and then accessed directly. Without VMM, I don't foresee many deployments leaving it at that. Interfacing with network controller directly is possible by tapping into its APIs with PowerShell, but is made even better by adding on a graphical interface on which you configure new networks, monitor existing networks and devices, or troubleshoot problems within the virtual networking model. This graphical interface can be used in System Center VMM. Network controller can be used to configure many different aspects of your virtual and physical networks. You can configure IP subnets and addresses, configurations, and VLANs on Hyper-V switches, and you can even use it to configure the NICs on your VMs. Network controller also allows you to create and manage access control list ACL type rules within the Hyper-V switch so that you can build your own firewall solution at this level. without needing to configure local firewalls on the VMs themselves or have dedicated firewall hardware. Network controller can even be used for configuration of load balancing and providing VPN access through RRAS servers. Generic routing encapsulation. Generic routing encapsulation is just a tunneling protocol, but it is imperative to making network virtualization happen successfully. Earlier, when we talked about moving IP subnets around and about how you can sit virtual networks on top of the physical networks without regard for making sure that their IP configurations are compatible, all of the functionality is provided at the core by GRE. When your physical network is running 192.168.0.x, but you want to host some VMs on a subnet in that data center, you can create a virtual network of 10.10.10.x without a problem. But that traffic needs to be able to traverse the physical 192.168 network in order for anything to work. This is where routing encapsulation comes into play. All of the packets from the 10.10.10.x network are encapsulated before being transported across the physical 192.168.0.x network. There are two different specific routing encapsulation protocols that are supported in our Microsoft Hyper-V network virtualization environment. In the previous versions of the Windows Server operating system, we could only focus on network virtualization, generic routing encapsulation, NVGRE, since this was the only protocol that was supported by the Windows flavor of network virtualization. However, there is another protocol called Virtual Extendable Local Area Network, VXLAN, that has existed for quite some time, and many of the network switches, particularly Cisco, that you have in your environment are more likely to support VXLAN than they are NVGRE. So for the new network virtualization platforms provided within Windows Server 2016, we are now able to support either NVGRE or VXLAN, whichever fits the needs of your company. You don't necessarily have to understand how GRE protocols work in order to make them work for you, but since they will be configured for you by management tools that exist in Server 2016, but it is important to understand in the overall concept of this virtual network environment that GRE exists and that it is the core secret sauce to making all of this work. Microsoft Azure Virtual Network. Once you have Hyper-V network virtualization running inside your corporate network and get comfortable with the mentality of separating the physical and virtual networks, you will more than likely want to explore the possibilities around interaction with cloud service provider networks. When you utilize Microsoft Azure as your cloud service provider, you have the ability to build a hybrid cloud environment that bridges your on-premise physical network with the remote virtual network stored in Azure. Azure Virtual Network is the component within Azure that allows you to bring your own IP addresses and subnets into the cloud. You can get a little more info and even sign up for a free trial of Azure Virtual Network here. https://azure.microsoft.com enus/services/virtual network/ Windows Server Gateway. When you are working with physical networks, virtual networks, and now virtual networks that are stored in cloud environments, you need some component to bridge those gaps, enabling the networks to interact and communicate with each other. This is where a Windows Server Gateway comes into play. Windows Server Gateway is the newer term for this piece. It was previously and sometimes still called the Hyper-V Network Virtualization Gateway. So you might see that in documentation as well. A Windows Server Gateway's purpose is pretty simple, but to be the connection between virtual and physical networks. These virtual networks can be hosted in your local environment or up in the cloud. In either case, when you want to connect networks together, you will need to employ a Windows Server Gateway when you are creating a bridge between on-premise and the cloud. Your cloud service provider would utilize a gateway on their side, which you would tap into from the physical network via a VPN tunnel. A Windows Server Gateway is generally a virtual machine and is integrated with Hyper-V network virtualization. A single gateway can be used to route traffic for many different customers, tenants, or divisions, even though these different customers have separated networks that need to retain separation from traffic of the other customers. Cloud providers, public or private, can still utilize a single gateway for managing this traffic because the gateways retain complete isolation between those traffic streams. Summary. Server administration and network administration used to be segregated pretty distinctively in most organizations, but over time, those lines have blurred. There are numerous networking configurations and tasks that now need to be accomplished by Windows Server administrators without needing to involve a networking team. So it's important that you have a good understanding of how your infrastructure connects together. Familiarity with the tools laid out in this chapter will provide you with the ability to configure, monitor, and troubleshoot the majority of Microsoft-centric networks. Our introduction to software-defined networking may be a particularly confusing section if you have never encountered this idea before. But hopefully it prompts your curiosity to dig a little deeper and prepare yourself for dealing with this in the future. The cloud is here whether we like it or not, and sometimes executive decisions pull it into our own environments faster than we would like to happen on the IT security side. The idea of SDN will grow in popularity over the coming years. It is one of those things that at the moment may seem unknown and daunting, but in 5 years, we may all look back and wonder how we ever made things work without virtual networks. There is much more information both in TechNet and in published books about Hyper-V, virtual networking, and System Center Virtual Machine Manager. So I'm going to do it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.